Okay, so happy Friday and welcome to the coding manual. And today I'm going to explain what is traversal in a binary tree, and that we will look at the level order traversal, and that will be with a question related to lead code question 102. It's in medium. Okay, so what does level order traversal means? Traversal level order traversal means suppose we have given a binary tree and binary tree is given as if this, and this is our given tree. So what we have to return in this question, what it says, we will look at the question soon. So we have to return list of list with in the level order. Okay, so in the first level we have 1, in the second level we have 2 3, in the third level we have 7 6 9, 7 6 and 9. So this we have to return. So let's quickly look at the question. So this one, given a binary tree, return the level order traversal of its nodes value, that is from left to right, level by level. For example, if this is the given tree 3 9 20 15 7, so I will take that itself, 3 9 20 9 20 15 7. Okay, 15 7. So output of this will be 3. See, in the list 3 9 20 and then 15 7. This is we have to return. So this is a famous problem, and we will be using something called BFS using Python DQ BFS, and BFS we will utilize the Python module DQ. Okay, and let's look at the DQ what it says. So I have the documentation open. DQ provides the it's in collection, and it provides the different methods like append, that will append the any element to the right side of DQ. So DQ is actually an a kind of array. Okay, it is a collection, and these are the methods. Append x, it adds x to the right side of DQ, and append left appends left to the DQ, that collection, and clear, remove all elements. Okay, remove all elements. So length of that DQ becomes 0. Extend the right side of the DQ by appending the elements from iterable argument. So if we are given some iterable here, so if we do q dot extend that iterable, it will extend to the right side. Same thing, extend left, pop left, and we will be utilizing only append and pop left of that DQ functionality. Okay, so let's understand. So uh, DQ will be something like this, and we will initialize as if DQ, and then we will try to append, and we will pop from q dot pop left. Okay, and this we will use like this. So let's see what will happen in this case. So what is the 3 9 20 15? 3 9 20 15 and 7. So we will use a DQ. Okay, so in DQ we will initialize and add. First we will put this in the queue. So we will put this in the queue and check. Until unless this is not empty, we will traverse that this queue and check at each level. So what we will make current level as empty list, and then we will see what is the length of this. Length of this right now is 1, so we will traverse till the length. So for I in range of length q, what we will do is we will pop left. Pop left means pop the element from the left side of the queue. So pop this one. So we got node as this one. So this we got q dot pop left, and this will give us 3. Okay, now we will what we will check is at the current level we will add the value of the popped node. Current level dot append, this is the list we have defined as an array, and then node dot value, and then we will check if left or right of this exists, so we will put that in queue. So now check if node dot left is there, then what we need to do, append that to queue. Queue dot append and node dot left. So 9 will come, this is popped out, so this is empty, so 9 will come here. Actually 9 will come here, and then same thing, if right, node dot right, then q dot append node dot right, right of that, and here it will become 20. So right now q has 9 and 20. Okay, now again after this what will happen, we will have a resultant array, resultant list. So in our current level we have 3 as the current level as a list, so we will add this particular to the resultant list. Okay, if result is empty, so finally in this we will say result equal to result dot append the current level. Okay, now we have 29 and 20 in the queue, and we will check while queue is not empty. So queue is not empty, so we will pop this, and we will check node q dot pop left, from the left side of the queue we popped 9, we got 9. So in the current level becomes empty here because we are checking from while queue, and the current level we have got 9, so current level append will be 9. So in the current level we will have 9, and then node dot left is there, this becomes false, and this becomes false for 9, and then we go back for I till length q is 2, so for 1 we have traverse, and now we will go to second element. We have popped this, now we will pop this 20. Now we pop 20, so we will check current level dot append 20. Now append 20 in the current level. Now check if left of that 20 exists. Yes, it exists. Then append that to node dot, this is actually 15, so this 15 will be appended here, so this will become actually 15, and then same thing, right exists, yes, so the current queue becomes this. So queue from beginning it happened like this: 3, 9, 20, then 15, then 7, but this was popped this was popped, this was popped, this was popped, and the last it will be popped. So ultimately we will have result as 3 920 and then 57. Let's do that in the code. So whenever we are given a tree and we have to do something, so first we will check if root is not there, then return empty array. Okay, and then declare a q as dq, and then append that root, root and then q while q. So you define current level as empty list, and then for I in range of q. Okay, pop a node q dot pop left, and then check. Before checking, we need to append that value to the current level dot append node dot val. And then if node dot left, then append that to q dot append and node dot left. Same things go with right, q dot append and then node dot right. In this case, we will, in the current level we have the all the values. Now result append current level, we need to declare result as an empty array, and this is done. Now we have to return the result. Int has no length. Okay, submit. Yes. Okay, so that's all. This, I think this was very easy, and this was the BFS style, breadth first search. What happens, like we traverse through in the on the width level. Okay, so this and then this and then this. Similar question we have in the LeetCode, as if given one binary tree, we have to return right view of this. Okay, right view, and we can utilize exact same solution to solve this question. Okay, so right view of this will be 3 20 7 27. This would be answer, and there is slight change is this in this solution, and we can do that. So I'll be in the next video, I'll be just solving this. Okay, thank you.